Today we are going to look at the topic indices, a very highly examinable area also. And to start with, indices, this is the plural of the term index. Yes. Now we are going to start by, first of all, when you're working out indices under mathematics is usually followed by certain rules. We have laws of indices. So we are going to begin with that. So I'm going to state the laws of indices. We have quite a number of laws of indices. These laws are the ones we are going to apply whenever we'll be working out any question in relation to indices. So let us first of all start with laws of indices. Laws of indices. Now, the first law of indices usually said, now I'm going to use algebraic expression to show those laws. So the first law states that if I have a number a raised to a power n, I multiply it with the number a raised to a power m. So if the basis has to be the same. If the bases are the same and the powers are different, usually come here, you combine that base with the powers being added, that is n plus m. So it means that when those two bases which are the same but different powers are separated with the multiplication, you are going to combine those two bases into a one base and then have the powers being added. That is the first law of indices. The second law of indices usually states that still the basis has to be the same, which is a raised to power n divided by a raised to power m. This one is the same as what? This one is the same as, now, because these two same bases but different powers have been combined with the division sign, then it means that the power, we are going to have a common base, which is a. Then the power are going to be combined with a subtraction. So I'm going to have here n minus m. That is the second law of indices. The third law of indices tells me that if I have an index a raised to power n into bracket m, so I'm having this index raised to another power m. Now, if I have that, we are going to multiply the two powers, which means for me to have a common number here, I'm going to have here a, so I'm going to have a raised to power n m, that is n multiplied by m. We have another law, that is law number 4. And law number 4, this one is in relation to inverse. Suppose I've been given an index 1 over a raised to power n. What am I going to have? Now, whenever you're having a 1 over a minus n, or a raised to power n, that one, the power is going to be reciprocated. That one, it's as if we are having an inverse. So I'm going to have a raised to a negative power of n. A raised to a negative power of n, because it's as if we are getting the inverse. So any number, when it is raised to a negative power, it means that possibly that number is an inverse. Possibly that number is an inverse. Rule number 5, though not that important, but actually it's very, very important. Rule number 5. Rule number 5 usually states that any number raised to power 0, the answer is always 1. So if I have a raised to power 0, the answer is 1. If I have 1,000 raised to power 0, the answer is usually 1. So those are the laws of indices we are going to apply as far as calculation of question involving indices are concerned. And mark my words, these laws doesn't mean that you just have to maybe see a multiplication for you to have this. Sometimes the examiner might decide to give you, let's say for instance, they give you a raised to power n plus m. This one equals to what? So you have to know this one, because it is the same base and the powers has been separated with the positive, you can split them. You can have this one being equals to a raised to power n multiplied by a raised to power n. So you can split sometimes. You can be given this, you're being told to split. So we can go forward or also backward. We'll see an example when we'll be applying this type of a criteria. Now, let us try an example. Suppose you've been given something like 64 raised to power x minus 2 multiplied by 8 raised to power 3x being equals to 16. Let's say for instance, so let us try that example. Now, first of all, we have to make 64, 8, and 16 to the same base. Remember, this formula can only work. Now, in most cases, not in all cases, in most cases, it usually works once we've made those numbers into the same base. Now, in this case, I'm going to make 64, 8, and 16 to the same base. And I know all those values can be raised to, can be raised to base 2. So it means that I'm going to start this one. When I raise it to base 2, what am I going to have there? I'm going to have this one, 64 is like 2 raised to power 6. So 6 into x minus 2. Then multiply by 8, I can raise it to power 3. 2 raised to power 3 into 3x. Then being equals to what? 16, that is going to be 2 raised to power 4. Now, once we've done that, first of all, we are going to open up the bracket that is on our powers. So I'm going to have here 2 raised to power 6. That is going to be 6x minus 12 multiplied by 2 raised to power 9x being equals to what? 2 raised to power 4. So, because the bases, we've already made the bases the same, we are going to cancel them out. They are not going to be helpful now at this moment. Remember, we are looking for the value of the unknown, which is x. Which means what I'm going to have here now, I'm going to have here 6x minus 12. And because these powers or this index, with these indices which were separated with the multiplication. Remember, I said if those two specific index are separated with the multiplication, then you are going to have an addition in between the powers. So plus 9x being equals to 4. We are looking for the value of x. I'm going to collect like terms in this specific case. So I'm going to have 6x plus 9x being equals, I'll take that negative 12, the other side it will be a positive 12. So I'm going to have here 4 plus 12. Which means I'm going to have here 6x plus 9x, I'm going to have there 15x. Being equals to what? 4 plus 12, 4 plus 12, that is going to be 16. So for me to get the value of x, I'm going to have here divided by 15, divided by 15, which means my value of x equals 16 over 15. Or you can write it into its simplest form, which means you're going to have 15 goes into 16 once, remaining 1 over 15. And that is our answer for the value of x. So we've applied the law of index, the first law of index, to work out that specific for the unknown, that is for the value of x. Let us try another example. So suppose we have a question like 81 x plus 3, then divided by 9 x minus 2 being equals to 27. Now let us work out that. Now the very first thing you have to know is that I have to make 81, 9 and 27 to the same base, of which in my case here I'll make them to the base 3 because 81, 9, and 27, both of them, all of them can be to base 3. So 81 is going to be 3 raised to power 4 into x plus 3 divided by 9 to base 3, it is going to be 3 raised to power 2 into x minus 2 being equals to 27, it is 3 raised to power 3. Let me open up the bracket containing the unknown, which means I'm going to have here 3 raised to power 4x plus 12 divided by 3 raised to power 2x minus 4 being equals to 3 raised to power 3. So because we've already made them to the same base, it means that the bases are not going to be that important at that specific point. We are going to take the powers, whereby my first power is 4x plus 12. Then because the two powers here are separated with a division, it means that instead of a division, I'm not going to have their subtraction, applying the rule number 2. That is, subtract 2x minus 4 being equals to 3. Which means I'm going to collect the like terms there. I'll have here 4x minus 2x plus 12 minus 4 equals 3. 4x minus 2x, that is going to be 2x. 12x minus 4x, that is going to be positive 8x being equals to 3. Then I'll take, no, this one is just going to be 8, not 8x, sorry. Then I'll take that positive 8 to the other side, it will be a negative 8. I'll have here 2x being equals to 3 minus 8, which means I'm going to have here 2x being equals to, that is going to be negative 5. Then for me to get the value of x, I'm going to divide both ends by the value of the coefficient of x, which is 2, which means that 2 and that 2 will cancel. I'll remain there with x being equals to negative 5 over 2, or it can also be written as 2 goes into negative 5, negative 2 times. So it is going to be negative 2, 1 over 2. And that is our value of x, as simple as that. So we use the laws of logarithm to work out that. Let us try another example. So suppose you've been given something like this, 8 raised to power 2x raised to power 2x minus 2 multiplied by 16 raised to power a half x being equals to 1 over 4. Now, first of all here, we are going to consider our bases as 8, 16, and 4. Let us make 8, 16, and 4 to the same base. Remember, 8, 16, and 4 can be made to base 2. Which means I'm going to have here, that is going to be 2 raised to power 3 into 2x minus 2 multiplied by 2 raised to power 4 into a half x being equals to what? 1 over 2 raised to power 2, because 4 is 2 raised to power 2. Now, there was a law I did talk about, but before we talk about that law, let us first open up the bracket that contains the unknown x, which means I'm going to have here 2 raised to power 6x minus 6 multiplied by 2 raised to power, now 4 multiplied by a half, that is going to be 2x, being equals to 1 over 2 raised to power 2. Now, in this specific case, remember there was a rule that we did talk about. It was under rule number 4. Whereby rule number 4, we said that suppose you've been given something like 1 over a raised to power n. This one is like an inverse, which means you're going to have a raised to a negative power. So in that case, it is going to be a raised to power n. Now, this law here, we are going to apply to work out whatever we are having on this other side. So instead of having 1 over 2 raised to power 2, I'm going to have here 2 raised to power 6x minus 6 multiplied by 2 raised to power 2x being equals to 2 raised to power negative 2. Why negative 2? Because this one is 1 over 2 raised to power n. And we are going to convert this one to this one using law number 4 of indices. So in that specific scenario now, I can solve for the value of x. Now, because all the bases are the same, it means that I'm not going to need them anymore. Which means what I'm going now to work with is the powers, which are the one which contain the unknown. Which means I'm going to have here 6x minus 6. Because there is a multiplication, that is going to be a plus 2x being equals to negative 2. Let us work out for the value of x. Let us collect like terms. I'm going to have here 6x plus 2x being equals to what? Take that negative 6, the other side, it becomes a positive 6 minus 2. Now, what are we going to have? I'm going to add here 6x plus 2x, that is going to be 8x, being equals to 6 minus 2, that is going to be 4. For me to get the value of x, I'm going to divide by the coefficient of x. My coefficient of x here is 8. So divide there by 8, divide this other side also by 8, which means I'm going to have x to be equals to a half. And that is going to be my value of x. And that is how we work out such an example. That is how we are going to work it out. Let us try another example also. So, this example here, 3 raised to power 2x plus 3 plus 1 equals 28. Now, such an example might seem problematic because you can see that 3 and 1, we cannot make them to the same base, and also number 2 also, it is separated with an addition, which we don't have any rule that entails addition in between two bases. But in this case, it is quite simple. Why? Because now 1 and 28, those ones are like terms. So it means that I'll take 1 to the other side, and 1 will become a negative. When 1 becomes a negative, it means that on my left-hand side, I'm going to be left with 3 raised to power 2x plus 3 being equals to 28 minus 1. Which means I'm going to have here 3 raised to power 2x plus 3 being equals to 27. If I want to work out that, I know now I can make 3 and 27 to the same base. I told you it is very simple. 3 and 27 into the same base, which means I can make them to base 3. So I'm going to have here 3 raised to power 2x plus 3 being equals to 3 raised to power 3 there. So because now I've made them to the same base, which means the bases are not going to be important at this specific moment. Now I'm going now to equate the powers of the two indices. So I'm going to have here 2x plus 3 being equals to 3. If I want to get the value of x, I'll take this 3 to the other side, it will be a negative. I'll have here 2x being equals to 3 minus 3, which means 2x is going to be 0. X equals 0. X equals 0. As simple as that. So that one was very, very simple. Now I want us to try one complicated question on indices. So let us try this. So this is the question. 9 raised to power t plus 1 plus 3 raised to power 2t being equals to 30. Now, such a question, how are we going to work out such a question? Now, number one, I know 9 and 3 can be made to the same base, that is to base 3. But I cannot make 30 to base 3. Yeah, the fact that a number can be divided by the base of those numbers doesn't mean that we can make it to the same base. 30 cannot be raised to base 3. We cannot raise 30 to base 3. But 9 and 3 we can. So, the very, very first thing, and then another problem we have here is that the two have been separated with a positive. And we don't have any like term that we can take to the other side to combine it with the rational number. Now, what are we going to do now? What we are going to do, first of all, let us make the ones we can make to the same base. Which means I'm going to have here 3 raised to power 2 into t plus 1 plus 3 raised to power 2t being equals to 30. Then I'm going to have here 3 raised to power 2t plus 2 plus 3 raised to power 2t being equals to 30. Now, again, I cannot combine this and this. Why? Because the sign that separates the two index is a plus. And in our laws of indices, we don't have any law that involves an addition in between two powers or in between two indices. So, what are we going to do? Now, we are going to split what I was telling you about in our previous session. That is, whenever you're given, sometimes you can be given something like a raised to power n plus m. So, this specific scenario, I know that I can convert this one back to what I had. Because the base is a, which means I'm going to have two bases. And because here it is a plus, it means that those two bases are going to be separated with a multiplication. And then I'm going to have each of the power taking each of the common bases, which means here I'm going to have n, here I'm going to have n. Because if we go back, we are going to have something of that specific case. Now, this specific thing, we are going to do it to what? We are going to do it to that. We are going to do it to this one here. So it means that I'm going to split this one. Because I'm having here a plus, there is none which has a plus here. So I'm going to split up this one. So because this one is in this form, I'm going to split it to have them like this. So this 3 is going to be the common base. So I'm going to have 3 raised to power 2t. Then because it is a plus, I'm going to have a multiplication. Then another 3 raised to power 2. So this 2t is the power of the first base, and then this 2 is the power of the second base. Then plus, so this 2, this one here, it is a split of that. It is a split of that. So, let us continue. So I'm going to have here 3 raised to power 2t multiplied by 3 raised to power 2 plus 3 raised to power 2t. 3 raised to power 2t being equals to 30. Now, from what I'm having there, I can see I have something common, especially the ones that contain the algebraic expression. I have 3 raised to power 2t and 3 raised to power 2t. Those ones are common. So we are going to you are going to assume that 3 raised to power 2t is something else, a certain algebraic expression. So let's say, for instance, in this case, I can decide and say 3 raised to power 2t, I can let it to be k. So anywhere there is 3 raised to power 2t, I'm going to replace it with k. Now what am I going to have? So using that equation, I replace 3 raised to power 2t with k. I'm going to have here k multiplied by 3 squared. Then plus k being equals to 30. Then I'm going to have here k multiplied by 3 squared, that one is 9, plus k being equals to 30. K multiplied by 9, that is going to be 9k, plus k equals 30. 9k plus k, that is going to be 10k, equals 30. Whereby, if I need the value of k, I'm going to divide here by 10, I'm going to divide there by 10, which means my value of k is going to be 3. And remember, 3 raised to power 2t was equated to k, which means 3 raised to power 2t is going to be equivalent to the coefficient of k, which is 3. Of which, if I have just a number like that, it means that it is raised to a positive power 1. So these 3 and these 3, because they are to the same base, they are not going to be useful anymore. We need to get the value of t. So I'm going to have here 2t being equals to 1. That is the powers. If I want to get the value of t, I'll divide there by 2, divide there by 2. Which means the value of t equals to And that is how we get the value of t. So always remember, whenever you're having this, you can split it and let the common index. So that is how we are going to get for the value of t, or the value of the unknown. Let us try another example. So we have this other example, that is we have here 125k plus 1 plus 5 raised to power 3k being equals to 630. Now, in this specific case, you're being told to get the value of k. Again, just like the previous index that we've done, this one also we are going to apply the same criteria. Number one, we cannot make 630 to the same base as 5 and 125. Number two, this even though I can make 125 and 5 to the same base, I cannot combine them. And why can't I combine them? I cannot combine them because the 2 has been separated with a plus, and there is no any law of indices that allow us to combine 2 index which are separated with an addition. So it means that, first of all, let us make this 125 and 5 to the same base, because we can make them to the same base. So let us start. 125 to base 5, that is going to be 5 raised to power 3 into k plus 1 plus 5 raised to power 3k being equals to 630. Now, let us get the let us open up the bracket. So I'm going to have here 5 raised to power 3k plus 3 plus 5 raised to power 3k being equals to 630. Then I'm going to split this one. Remember, I said we are going to split it using that rule, that is a raised to power n plus m. This one is going to be equals to a raised to power n multiplied by a raised to power m. It doesn't have to be a plus and a multiplication. Sometimes when here it is a minus, you are going to separate them using a division. So we are using the multiplication because here it is an addition. So what I'm going to have here, I'm going to have here 5 raised to power 3k multiplied by 5 raised to power 3 plus 5 raised to power 3k being equals to 630. Now, in this specific scenario, I'm going to let, because I have 5 raised to power 3k and 5 raised to power 3k being a common one. So I'm going to let 5 raised to power 3k to be, let's say for instance, to be a. So where there is 5 raised to power 3k, I'm going to replace it with a. So I'm going to have here a multiplied by 5 raised to power 3 plus a being equals to 630. Whereby I'm going to have here 5 raised to power 3, that is 125. So I'm going to have here a multiplied by 125 plus a to be equals to 630. To be 630. So after doing that, we are going to say a multiplied by 125, that is going to be 125 a plus a equals 630. 125 a plus a, I'm going to have there 126 a being equals to 630. If I want to get the value of a, I'll divide here by 126, I'll divide here by 126, which means a is going to be what? 630 divided by 126, that is going to be 5. Now, I've gotten the value of a to be 5. And remember, I had assumed that 5 raised to power 3k is a. So it means that I'm going to come here and say 5 raised to power 3k equals to the value of a, which we've gotten as 5 raised to power 1. Which means this 5 and this 5 is going to cancel, because already we have them to the same base, so they are not going to be useful past that. So what I'm going to remain here with, I'm going to have here 3k being equals to 1. If I want to get the value of k, I divide there by 3, I divide there by 3. And k is going to be 1 over 3. And that is how we work out for the value of k. Let us try another example. So you're being told solve for x in this. So we have in here 2 raised to power 2x, then minus 18 raised to power 18 multiplied by 2 raised to power x equals to 40. Now, an example like that, how are you going to work it out? Number 1, this and this are to the same base. They are to the same base. This and this, I cannot make them to the same base. Though I can combine them because they are like terms, but I'm not going to combine them in this specific scenario first. Now, in this specific case, we are going to form a quadratic equation. Now, first of all, because this and this are almost similar. Why am I saying they are similar? Because this one can be written as 2 raised to power x bracket square. Remember that rule? The rule number 3. The rule number 3, whereby we were saying that a raised to power n m, this one is the same as a raised to power n m. So I can split it also. I can take it back to that, to have something like that. Minus 18 multiplied by 2 raised to power x being equals to 40. Once I do that, once I do this to this, I realize that I have here 2x and here 2 raised to power x, which are similar to one another. So what am I going to do? I'm going to let me let 2 raised to power x to be t. Let me let it to be t. So where there is 2 raised to power x, I'm going to put t. So I'm going to have here t squared, that is t, and then that square, then minus 18 times t equals 40. Here, first of all, 18 multiplied by t. And that is the reason why I said you cannot take it to the other side, because of this multiplication. This multiplication is going to allow you to combine this and this. So I'm going to have here 18 multiplied by t to have it there as minus 18t being equals to 40. When I see t squared, 18t and 40, I know this one can be a quadratic equation, because this one is going to be my, remember, a quadratic equation should be in form of ax squared plus bx plus c equals 0. So ax squared is this, bx is this, and c, which is the constant, is that. So I'll bring this to this other side so that I can form that quadratic equation in this specific form. So I'm going to have here t squared minus 18t minus 40 being equals to 0. Now today I want us to use let us use the factorization method to get the value of t there. Now factorization method, I'm going to get the product and the sum. Product and the sum. So product, I'll take the first value there, I multiply it with the last value. That gives me the product. So it means that the product here, remember it is the values. Here it is like 1. 1 multiplied by negative 40, which means my product is negative 40. What about my sum? This value here is usually my sum. The mid value is your sum. So I'm going to have my sum as negative 18. So I'm going to look for two numbers. These two numbers, if I multiply them, I get negative 40. If I add them, I get negative 18. Which values are these? Now, the values are negative 40, negative 18. I can have there 20 and 2. That is going to be negative 20 and positive 2. Very good. Negative 20 and positive 2. When I take negative 20 multiplied by 2, I get negative 40. If I take negative 20 plus 2, I get negative 18. So, once I've gotten those two values for the product and the sum, I'm now going to replace these two values. Where there is 18t or where there was the sum, I'm going to omit the sum and replace them with those two values there. So I'm going to have here t squared minus 20t, then plus 2t. This 20 and these 2 here they. Then minus 40 equals 0. Whereby I'm now going to pair them like this. Pair it like that. pair that one also like that. T, I'm going to look for the common factor in the first bracket. The common factor there is going to be t. So I'm going to factor out t. T goes into t squared, that is t minus 20. Then plus, in the second bracket also I'm going to look for the common factor. In my second bracket, the common factor is going to be 2. So 2 goes into 2t how many times? T minus 2 goes into 40, 20 equals 0. Which means, if I want to get the value of t, I'm going to take one of the common one, which is t minus 20. Then I take that, I combine it with that. So I'm going to have there t plus 2 equals 0. I can get two values of t. Remember, quadratic equation usually gives you two values of the unknown. So I'm going to have here t minus 20 to be equals to 0. When I take negative t to the other side, it will be positive t. So I'm going to have there t equals 20. So the first value of t is 20. The second value of t, I'm going to have here t plus 2 equals 0. Take that to the other side, it will be a negative. So I'm going to have here t equals to negative 2. Remember, the value that we did let to be the value of t was 2 raised to power x. So I'm going to equate this 2 raised to power x with both of them. So I'm going to start here with 2 raised to power x equals to the first value of t, which is what? Which is 20. Now, there is a beautiful twist we are going to see there. 2 and 20 cannot be made into the same base. If I cannot make 2 and 20 to the same base, what am I going to do now to solve for the value of x? You are going to apply logarithm. You are going to apply logarithm. Now, this is a rule that you have to know. Whenever you cannot make the two values into the same base and it is at the end of it, we usually introduce logarithm. So I'm going to come here say, for this one, logarithm, we are going to get the log of 2. So I'm going to have here x, that is that x, log 2 being equals to log 20. So it means that in this case here, I'm going to be, if I want to get the value of x, I'm going to divide there by log 2. I'm going to divide there by log 2. This log 2 and this log 2 are common, so they are going to cancel. I'm going to remain with x to be equals to what? Now, log 20 divided by log 2. Don't cancel the log. Kindly, don't cancel the log. If you cancel the log, you ruin everything. We don't cancel the log. Just go to your calculator, put log 20 divided by log 2. Let me get that. Log 20, log 20 divided by log 2. Divided by log 2. So it means that the value of x, when you divide that, you're going to have 4.321. The second part of it, remember we are going also to equate it to negative 2. So when I come here say 2 raised to power x equals to negative 2, we cannot make this and this to the same base. Yeah, negative 2 and 2, we cannot make them to the same base. So in that case, x is a complex value. Yeah, in that case, x is a complex value because we cannot make 2 and negative 2 to the same base. So in this case here, x is a complex value. Are you together? So here, x is a complex value. So possibly the value of x here is going to be 4.321. And that is our final answer. So with that, that is what we have under indices. That is what we have under indices, and hope at least you've learned out some